Hi, welcome to product review by Watt Hour. In this video we are going to review this XH-M240 battery capacity tester and discharger for 18650 lithium battery and other type of batteries. I'm going to explain the module, show you how to use it. Then we are going to test the capacity of lithium battery for the period of 5 or 6 hours. I'm going to use thermal camera to show you which spot is getting hot the most. I'm also going to measure the current of the battery when it's being discharged. Also, I'm going to show you to power this up using external power of 5 to 12 volts. You can get the resources for this video by visiting our website watthour.ca. A lithium battery has certain life cycle, meaning that you can charge a battery up to a certain number of times. As the time passes, amount of charge that it can hold will be reduced. And also, for example, for certain batteries, you cannot charge it more than 1000 or more than 2000 times. For example, this battery, if we look at the data sheet, for example, this lithium battery NCR18650, and this is the life cycle count. At the bottom it says life cycle count, and as you charge it 100 times, 200, for example, up to 500 times, you see that initially at 0 it was around 3200. As the time passes, when you reach 100 times charging, it will be less than 3000 milliampere hour. At around 300 it becomes 2500. When you charge it up to 500 times, you will see that it will be 2200 milliampere hour. So the capacity will be reduced as the time passes. For that purpose, you need to know and check the capacity of your battery. And one of the devices that is sold is this module, which I'm going to explain it fully, so we can discharge the battery, read the capacity, and see what is the capacity of your battery. I bought the module from this store, and so many people are selling this. I bought it for $6.70 with some shipping to receive it in 30 business days. If you search AliExpress, you will see tons of stores are selling it. This is the module. It can discharge only one battery, and we have a 8 ohm 10 watt resistor here. This is 8 ohm with the letter J. This means it has 5% tolerance, and which means the measurement that you have will be 5% low or high. In order for this to operate, we need separate voltage source, so you can power it up using these 18650 lithium batteries. So 18 is the diameter, 65 is the length. So 18650 battery, and here I've soldered a wire to power it up from external source of 5 to 12 volts. Connector that is used to power it up from external source, XH-2.54 2-pin. The circuit is operating with 3.3 volts, and we have a power switch which you turn it on and off. And if I insert this battery here to power it up, it shows 0. This is treated as V, so 0 volt. First, when you insert the battery, make sure it is turned off and insert your battery. And now when I turn it on, it shows the voltage of this battery. Right now it has been reduced to 3.6 volts, and the LED in here is now off. It means that this is ready. So we have 4 push buttons here. This push button is to start and stop the discharge. When I press it, now the light is on. The discharge has started. And when I press it again, it will turn off. When you press this push button, and it is milliampere hour, amount of capacity that has been drained from this battery. If I press it again, it goes to milliwatt hour to the next light, and this is the milliwatt hour amount of energy that has been drained. And if I press it again, it shows the voltage of the battery that you are working with or draining. We have 2 push buttons here that we set the limit for the amount of voltage for the battery to be drained. When you drain the battery or discharge it, the voltage of the battery is being reduced, and it continues reducing it, but we have to stop it because lithium battery will get damaged if you go beyond a certain value that is defined by the manufacturer. And this is the data sheet for the Panasonic NCR18650 battery that I have. The capacity is 3200 milliampere hour, and the nominal voltage is 3.6 volts, which means we call it 3.6 volts battery or 3.7 volts, not 4.2. But when it's getting charged, the maximum voltage that it reaches is 4.2 volts. This graph is for the discharge, and the cutoff voltage is 2.5 volts for this battery. So you have to find out the discharge cutoff voltage for your battery. So we know that the discharge value for this is 2.5 volts. We will set it from these two push buttons. So when I press the left one, the value will be reduced here, and if I press it again, it will be increased. So we can set this to 2.5 volts. Now if you wait, this V mean, this U is treated as V, 2.5. Now it turned back. Now it shows the voltage of the battery, 3.6 volts. So it is now on. The battery will be connected to this resistor via these two tiny MOSFETs, and all the current that passes will go through this small resistor here of 20 milliohm, which I'm going to show you under digital magnifier, so you will see it larger. The microcontroller is controlling all these settings, and they have wrapped all the values for this, so we don't know except this regulator, which is 3.3 volts, which gets up to 12 volts and converts it to 3.3 volts, and the voltage from this battery will be also converted to 3.3 volts, so everything works with 3.3 volts. Now let me show you the thermal image. This resistor is now slowly warming up. It's not hot, but let's see it. As you can see here, it shows 48 degrees Celsius across this point. If I put my pen, you will see that this is the item that is getting hot. Now let's have a look at the components one by one. First, this one. And this is 6203. This is the datasheet for XC6203. This is the large current positive voltage regulator, and this can be used from 1.8 to 6 volts. And the one that we have here is 3.3 volts. Let's have a look at this chip. We don't have any label on this. It has been cleared. Let's have a look at this chip. Amazing. This has also been cleared. And this one, definitely this is a microcontroller, but let's have a look at it. So this has also been cleared. Regulator here, also it has been cleared. So now let's have a look at this chip beside the resistor, very tiny one. So this also, the model have been wrapped off. And now let's have a look at this resistor here. And as you can see, this is a 0.02 ohm or 20 milliohm resistor, where all the current from the battery will pass through this, from this terminal. Everything comes and passes through this. So we will measure the amount of current via this resistor. Now let's talk about the capacity and energy for the battery quickly. We have a rated voltage, for example, for this battery is 3.6 volts. And we have the capacity 3200 milliampere hour, and we have a discharge voltage of 2.5 volts. So these are the important parameters that you must know. Plus also they call it 1C. 1C means one capacity of the battery. If you see the word 1C, it means 3200. And to calculate energy, we have the capacity 3200 milliampere hour or 3.2 hour. So energy is equal 3.6 volts times 3.2 ampere hour, 11.52 watt hour. So this is watts hour, but this screen shows milliwatt, so this will be divided by 1000, 11,520. Discharge current, we have the battery voltage, for example, at the moment it is 3.6 volts. And we have a resistor of 8 ohm. This resistor is now, you see, it says 8 ohm. And by Ohm's law, I is equal V over R. So 3.9 volts divided by 8, 0.487 ampere, or 487 milliampere. At 487 milliampere per hour in 1 hour. And if we divide it by 60, we get 8.1 milliampere per minute. And because now 8.1 milliampere per minute, and we have to divide it again by 60 seconds, so we get 0.135 milliampere per second. So keep that in mind. And if you want to find out that discharge time, the capacity of the battery is 3200, and if you divide it by 487 milliampere, so it will be discharged at 6.5 hours, 6.5 hours. This battery will be discharged with this rate. Now let's see how much current this consumes. Now I have connected ammeter here in series with the battery. The positive is connected directly. The negative goes to this ampere meter and comes back. Now let's turn this on. As you can see, it shows not on. The reason for that is when I connected this, it was already turned on. So I have to turn this off and turn it on again. Now if I check this, the voltage is set, the minimum voltage for the battery to be discharged for this battery. Let's just press it. Now the discharge has started, and this is the current that is being consumed from this battery, and that is the rate. And if I press this, I will see the milliampere hour that has been drawn, so with the time. And if I want milliwatt hour, that's the unit. So with this we can switch it. At any moment I can return back to this voltage of the minimum voltage. The battery is 3.2 ampere hour, and we are consuming 0.5 ampere per hour. So 3.2 divided by 0.5, and it will take 6.4 hours to drain this battery fully if it was fully charged from this battery. Let's measure the voltage across this small resistor here. This is the resistor where the current is being measured, and I'm going to connect it here and see. So we read 10.3 millivolts, and this is 20 milliohm. So I is equal V over R. V is this one. .03, so that is millivolts for this, divided by 0.02 milliohm, 0.02 ohm, and the current is 515. The setting that we have here is set for 3 volts. For the discharge value, when it reaches at 3 volts, it will turn off. And in case if you turn this off, when you turn it off and turn it on, if we check it, it's there. Now let's even disconnect the battery, both of them, and then let's put it back. And let's check it. So it memorized it, and even if you disconnect the power, it keeps the setting. Now I'm going to power this up using an external source. First, let me show you the voltage. And as you can see, it is 12 volts. So we have 12 volts external source. Let me connect it to these wires. And it turned on. So now it's powered up using external power. Let me show you the amount of current that this one needs. I've connected ammeter or ampere meter in series with this. So let's turn this on. And as you can see, it shows 16, 17 milliampere, about 14 or 11. It jumps continuously. So let's turn this on, and now this is operating. So this goes on and off, which means it does not draw the current continuously from the battery. This is now a fully charged battery, both of these. I'm going to show you, I'm going to put, so you can see the, first power this up. Let's power it up. As you can see, this is fully charged and the voltage is 4.2. And let's press the start. The start started. From here we can see the unit. Now it's milliampere hour. It will start, and this will show watt hour. And from here we can set the voltage to 2.5 or whatever voltage, but for this battery it was 2.5. So I'm going to leave it at 2.5 and we are going to check the capacity. Now let's check the capacity of this battery. It will take maybe 7 to 8 hours. I'm going to put the camera, replace the micro SD card, which is 32 gigabytes continuously, so we can see how long it takes. And from time to time I'm going to show you also on the screen the capacity and the voltage if I can. So 2 watts have been dissipated so far. Voltage is 4 volts and 546 milliampere hour have been drained. So 3078 milliwatt hour, this is 3 watt hour, have been dissipated. The voltage is now 3.8 volts and 833 milliampere hour out of 3200 have been drained. Now 1353 milliampere hour capacity have been drained, and 5000 milliwatt or 5 watts have been drained from the battery. The voltage is now 3.6 volts. Let's go back to milliampere hour. Let's check now the capacity is 1498, that's 1.5 ampere hour have been dissipated or drained. 5.5 watt hour, that's 5000 milliampere hour, and the voltage is now 3.6 volts. So we have long time left to reach that. Now we have drained 1.7 ampere hour or 1700 milliampere hour. If I switch it to milliwatt hour, it's 6290 or 6.3 watt hour, and at the moment the voltage is 3.5 volts. So we are waiting until it reaches 2.5 and it will stop. And as you can see, after 7 hours and 7 minutes, the voltage reached to 2.5 volts and the drainage from the battery is stopped. The total capacity that have been dissipated through the resistor is 2370 milliampere hour. I've used this battery like 5 to 10 times. I've not even used it more. So it seems that they are selling the battery with fake numbers on it. So these capacity testers are very helpful, and I will try to make a lot of other videos testing the batteries with different tools and give you the actual right number so you can decide when you purchase the battery. And now this is 7 hours and 7 minutes in very fast speed in 1 minute, so you can see the time in terms of hour, minutes and seconds, and also the last one is a frame, and it will show you also the capacity when it reaches to the 2380 milliampere hour. Now, for conclusion, I will say that this is a very convenient way to discharge a battery and very easy to use. Amount of current that this can discharge, as I've shown you, is 500 milliampere, and depending on the capacity of your battery, it will take hours, and it just drains it to this high power resistor to discharge your battery. So if you don't have other means to discharge a battery, this is a very good solution, and the price is not as cheap as I thought, but because you can operate it also from external power, that makes it convenient. Thank you for watching. This was the full review of this XH-M240 Discharger. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. This TP5100 lithium battery charger for 1 or 2 cell. So this is my negative for the charger, and that's the positive. So to connect that 3-cell lithium battery charger, you might see it in different shapes. What type of source you need, that is the most important one that I'm going to explain. For this one, you need to have a module that has constant current and constant voltage.